Hello, I am one student, and this is a video for lesson 622, including the warm-up. So the warm-up tells you to solve this system of equations. You should have had your toolkit note that says, it talks about the equal values method, and this is the method that we'd be using for this one. When we solve a system of equations, our answer is going to be a coordinate point of where they cross. So I'm solving for x, and then I'm solving for y. So when I have this system of equations where I have x is equal to something and x is equal to something, I can actually put these two together and solve for y. So I'm going to do that now. 2y minus 7 is equal to negative 3y plus 13. So now I have one variable. I should be able to get a value for y. So now I'm going to add 3y to both sides of my equal sign. This one goes away, so I end up getting 5y minus 7 is equal to 13. Now I'm going to add 7 to both sides of the equal sign. This goes to 0, so I end up with 5y is equal to 20. And then my last step, I'm going to divide both sides by 5. 5 divided by 5 is 1, so we're left with y is equal to 20 divided by 5, which is 4. So I know my y value is 4. But now I need to know my x value of this coordinate point. So what I'm going to do, I'm going to put it back into one of these equations. So I know my x is equal to 2, but instead of y, I know my y is 4. So I'm going to enter in 4 here, minus 7. So when I do the calculations, I end up with 4 times 2 is 8 minus 7. X is equal to 1. So your answer is going to be this coordinate point, or you can write x is equal to 1, y is equal to 4. Either one of those answers is correct. So again, this is called the equal values method. I do not want you to memorize this. I just want you to understand how to use this to solve a system of equations efficiently without too much work. All right, so let's move on to the next part of our lesson. This was our warm-up for today. Our lesson is, if I give you this system of equations, notice that I have a y equals on this side, but not on this side. In order to use the equal values method, I need to rewrite it so it says x or y equals something on both sides. So let's do that now. I'm going to solve for y, so I'm going to subtract 3x from both sides. And notice that this 3x and these two are not like terms. We can't add them together. This goes to 0. I get 5y is equal to minus 13 minus 3x. I divide both sides by 5. This ends up being 1, so it's y equals 13 over 5 minus 3 over 5x. Well, look at that. Now I have y equals here and y equals here. I can set them equal to each other. So let's do that. Negative x minus 7 is equal to 13 over 5 minus 3 over 5x. Oh, look at those fractions. Don't be afraid. Let's keep going. So I'm going to add the x's to both sides. I'm going to add 3 over 5x to both sides. Remember that 1 is the same as 5 over 5. I'm going to keep my denominators the same, so it makes it easier. Negative 5 plus 3, well, that's negative 2x. 2 over 5x minus 7 is equal to 13 over 5, because remember, this goes away. So now let's look at this. Well, I want to add 7, but remember, 7 is the same as 35 over 5. So I'm going to add 35. Oh, did I miss my negative? I did. Look at that. I need a negative here, and a negative here. All right, so it's going to add 35 over 5. So what happens is this cancels out. So I'm left with, and I'm going to bring this over here. So let's make sure that we're not mixing this up. Negative 2 over 5x, remember this one away, is equal to 35 minus 13 is 22 over 5. Lastly, I'm going to divide by 2/5. Divide by negative 2/5. Remember that we have to invert and multiply. So my x is equal to, what is this? This is going to be 5 times 22 is 110 divided by 10, which is negative 11. There's my x value. So again, my answer is going to be in a coordinate point form, or you're going to have x is equal to, my x value here is going to be negative 11. Now I'm going to put that negative 11 in for y. Let's make it easy on ourselves here, guys. Scroll down a little bit. So we're going to pick this equation, the first one that looks like the easiest, where I'm going to put, instead of x, I'm going to put negative 11 minus 7. That ends up being positive 11 minus 7, which is 3. So my y value is 3. That seemed like a lot of work. What if there was an easier way? What if I could show you an easy way to find the same answer, but a different method? Not the equal values method, not the where we had to rewrite this whole equation. We want to get rid of this part right here. We don't want to have to rewrite. We just want to use what we have to find out our coordinate point, where they cross. All right, so I'm going to do this in a different color. So I'm going to rewrite the equations over here. And then 5y plus 3x is equal to negative 13. Okay, so notice that y equals, I'm going to highlight this, y equals negative x minus 7. And I have a y over here in the second equation. Remember, these are two different equations. I have a y over here, and I have a y equals right here. What if I substituted this information into here? So instead of setting them equal to each other, I'm going to take this and put it right into where y is. And I'm just going to rewrite the second equation. So I'm going to write 5 instead of y. I'm going to write negative x minus 7 plus 3x is equal to negative 13. Look at that. No fractions. Super easy. And now I have one variable. I can find the value of x. So I'm going to multiply or distribute that 5 in to both sides of the equation. I get negative 5x minus 35 plus 3x is equal to minus 13. Now, hopefully you guys are seeing that you're just going to solve for x. We're combining those like terms. So I'm going to add 3x. I'm going to add these two together. I get negative 2x minus 35, not 3x. Yeah, going crazy. Minus 35 is equal to negative 13. Now I'm going to add 35 to both sides. This goes away. I get negative 2x is equal to negative 22. Oh, actually positive 22. Divide by negative 2. X is equal to negative 11. Look at that. That's the same. And no fractions. So nice, right? So if this is negative 11, my answer for y has to be positive 3 because, look at, I put that negative 11 into this equation and I got 3 out. I hope that looks like an easier way to find the solution or the point of intersection of those two equations, that system of equations. All right, let's do one more together. We're going to do this one. Again, we're going to use our what we call our substitution method. We'll put that in our toolkit tomorrow. But right now, I just want you to practice. So notice I have an x equals something. That's right here. And I'm going to put it into here. And I'm just going to use this equation to solve for my variable. So I'm going to go like this. Instead of 2 and then times, instead of x, I'm going to put 2y plus 8 plus y is equal to 16. All right. So now I have one variable. I should find the value of y. So I'm going to multiply that 2 into my parentheses. Get 2 times 2, that's 4. So 4y plus 2 times 8 is 16. Plus y is equal to 16. Now I'm going to add my like terms together. I end up with 5y plus 16 is equal to 16. I'm going to subtract 16 from both sides. This goes to 0. Oh, look, this goes to 0 as well. I got to still write the 0 over here. And one more thing, I got to divide both sides by 5. This goes to 0. Y, what's 5 divided by 0? It's just 0. There's my y value. So my answer, oops, I keep hitting that button. My answer for y is 0, or y is equal to 0. Now I got to find what x is equal to. All right, I'm going to put 0 into one of these equations. I'm going to choose this top one. So x is equal to 2, but instead of 0, y, I'm going to put 0 plus 8. That's this equation right here. Ooh. X is equal to 2 times 0 is just 0, plus 8 is 8. I don't know, I have a parenthesis right there. Sorry, guys. So my x is equal to 8. And there's my answer. All right, I hope this video has been very helpful. Please make sure you ask questions, and I'll see you in the next one.